Good morning, everybody. Welcome. Set up. As mentioned before, my name is Vivian Trotter, civil engineer, and here as part of the public education program that the NBD is hosting on behalf of prospective and existing homeowners. The engineer is part of a team of professionals that are involved in the home building process. You have the architect or draftsperson, as the case may be, the engineer, the quantity surveyor, and the contractor. Each one plays a vital role in the whole process, and it is good for you to know the role that each plays. As mentioned before, I think it was last year, the architect and the quantity surveyors were here. But just as a brief reminder, the architect is the one who designs the spaces of the building, says how and the location of where things are, where the living room is, where the bedroom is, how big they are supposed to be. He also is responsible for the aesthetics of the building. The engineer, on the other hand, deals with the strength of the building. The building or building structure, as the case may be, is expected to last 60, 75 years. And in the course of that lifetime, it will undergo many things, many experiences. In this part of the world, apart from the normal loading that is expected in anywhere, in any building, we have the issues of earthquake and hurricane. So a comparison is given here. If a structure was a human body, then the architect would be concerned with the body shape and appearance, and the structural engineer would be concerned with the skeleton, the bones, and the muscles that will make the building stand up and withstand whatever push, whatever shove, whatever else comes on it. And you don't want the building to fall down. The engineer is the one that will prevent it from doing so. What does that change? Now, in this presentation, time is short, so I will just go through certain topics that engineering is involved in the whole process. We have the site preparation, we have earth movement, we have the considerations for earthquake and hurricane, and we will touch briefly on concrete. Site preparation. Now, when they usually engineer or the architect, as the case may be, comes into the picture after the land has already been bought. So we have to make do with that situation. When the client is ready now to start to build the house, he engages his architect. He may not necessarily engage the engineer at that point, but it would be useful to have an engineer look at the site prior to building, or prior to even designing the building, because one has to take into account the nature of the soil, the nature of the topography of the land, whether or not you have any risk in terms of storm water, that is rainwater running through the site, whether or not the soil is strong enough, of course, to support a building, whether it requires retaining walls, whether or not the land is prone to slippage. We also want to find out if it's suitable for septic tank and soak away if it is out of the urban area. We want to know where the land drains to, if that is an issue. So all that impacts upon the design of the building. how big the building shall be, how tall you can go, how wide you can go, as the case may be. We also want to know if you have easy access to the site, if you can drive onto your site, if your vehicle can come and drive underneath your house or next to your house, or if you have to leave it parked by the road. All these things you need to know up front. Is there any evidence of termite infestation? That is a major problem in all tropical countries. Termites are part of life. But we want to know if there is any evidence of intense infestation within the property. As I say, I'm trying to go through as quickly as possible and touch on all the major points. All right. Also, if you have a surveyor's drawing of the plan, of the property, that's very important to know where the building shall go. And if you're not building on somebody else's land, as has happened in the past, you also want to know where the boundary points are, so the building will go where it is intended. Of course, planning permission should also always be obtained. The bank will require that as part of the documents required for processing the application. Now we have to look at site clearance. Something happened here. All right. So after the plans have been prepared or during the course of the preparation of the plans by the architect, not in every situation, but there are some situations where the engineer and the architect have to work together in the preparation of those plans. Planning has their requirements as far as the official collaboration of the engineer with the architect in the plans. These criteria include or depend on the size of the building, essentially. If the building is more than 3 stories, you require engineer certificate. If the spans of the slabs are beyond 13 feet, you require engineer certificate. If the span of the beams are beyond 16 feet, they require engineer certificate. But that is just a document required for planning. It does not mean that if it does not meet those criteria, that you cannot make use of an engineer. An architect or a draftsperson are not trained in engineering or have limited training in engineering. So while they may make a building or have the knowledge to make a building safe in terms of the design, it may not necessarily be economical. So that is where the engineer comes in. He can prepare a structural design that is both safe and economical. That's the important part. Because anybody can build a very strong building, but you don't want to spend 100,000 when 50 will do. So, let us start. The plans have been approved, engineer has made his input, we're ready to start construction. First thing you have to do is clear the site. So, we have excavation. If it is not too deep, we do not need anything to hold up the sides of the soil. If it's deeper than a certain amount, we might need, especially in Roseau, you might need things to hold up the soil because the soil keeps falling in. It all depends on the nature of the soil at the respective site. Backfilling. After we dig, we have to put back. Now, particularly for ground floor slabs, which I call a slab on grade, we do not want to have more than 3 feet of fill underneath that slab. Many times you find it's quite common practice here that they build the foundation walls and they just come and they fill up the space and then just compact the top. That is not good practice. To do the big backfilling in the proper way, you're supposed to fill it in layers and compact each layer as you're coming up. Because over time, that more than 3 feet of soil that you have put underneath the slab will sink. And because the slab has not been designed to be suspended, it will sound hollow, it will start to sag, the walls and them will start to crack, the doors wouldn't be able to close, and you'll get all kinds of problems associated with that. So if you can avoid fills of more than 3 feet, please do, or ask the designer to design your slab for you as if it were a suspended slab. That's why I talk about compaction. Soil does not have any strength without compaction. And compaction is a tedious process, but the only way to do it is in layers, maximum 6 inches, compact it well, add water, the correct amount of water that is, because too much, it will be too soggy, too little, it will never compact enough. So this is a very common mistake or shortcoming, so to speak, during construction in this country. I have it. Sorry for the little technical issues. But farmer. Anyway, now this part of the world is known as an earthquake zone. I think we missed a couple of slides anyway. All right. Okay, we'll take it as it is. Earthquakes involve the shaking of the ground to which the building has to react. Now this shaking could be both horizontally, any direction. It can also be at the same time up and down. So you know it is a difficult thing to design against. Nevertheless, there are certain points that we must bear in mind when we're looking at making our houses, our buildings, earthquake resistant. Fortunately for us, the most residential buildings are 1, 2 floors, and they're not as affected by hurricanes as would taller buildings be. Nevertheless, the type of soil that the building is on is very important. And if you have loose material on which the building is placed on, the whole building could end up toppling. Also, if the building is close to the sea, you have the issue of tsunami. Just recently, there was talk about this volcano in offshore in Grenada, one they call Kikemjeni. Now, it has been active for some time now, and it is expected sooner or later it will explode. And when that happens, because it's in the sea, it's quite likely that there will be a tsunami generated, and there's no barrier, so to speak, between them in Grenada and Dominica here, so it's expected that there will be some tsunami effect. Of course, it wouldn't be as tall or as high, rather, than it would be somewhere closer. But nevertheless, if your house is close to the sea, you could get something happening to it as a result of tsunami arising from earthquake. Now, also, the shape of your building is important in terms of how it resists the earthquake. The best shape is a simple rectangular shape with the length not more than 3 times the width. So if the building is 30 feet wide, it shouldn't be more than 90 feet long. If it's too narrow a building, when the ground shakes, it's more likely that it will have some damage to the building. If it is longer, we've got to divide it up into separate structures. So with the movement, you don't get any kind of damage occurring. The openings must also be situated away from the corners of the building. Bringing it too close to the corner weakens the building and therefore make it more susceptible and more vulnerable to earthquake damage. masonry. Now, it is quite common. Blocks, building blocks is very, very common in Dominica. Everybody is a mason. Everybody can build blocks, you know. But most important, and not always followed, is the fact that the pattern of laying the blocks must be adhered to. These lines must match up. It cannot be any old way. That pattern must be followed. Because there are holes in the block which are filled with concrete and steel as well. Not every floor, but below the ground level, every floor is filled with concrete. But once it gets above the floor level, you have steel running through. And that same floor has to have concrete. But if it doesn't match up the way through here, you will get a discontinuity in that concrete color. And the wall will never have the strength it's supposed to have. So although you have everything that it's supposed to have, but because it is not placed properly, the wall is not as strong as it's supposed to be. Purely because the mason decided that it's easier just to put the block any old way than to place it in this fashion. Also, the steel must be continuous from bottom all the way to top, so that the wall is held both at the bottom and at the top. So when the building shakes, the wall doesn't fall down. That's what you're trying to prevent. The gable ends, like you see this end of the building there, I'm not looking at the screen now, the building itself, this part up here, between the horizontal member and the roof, that set of block work up here, many times the blocks are just placed there without any steel in them. And there's no beam running on the sloping side of the wall, on the top. They have a beam at the horizontal level, but it doesn't also go up to tie that triangular piece of block work there. Many times they just first put the block work, just fill up the space, man, between the beam and the rafter. But that is a weakness in the house. When the house shakes, that little piece of wall on somebody. In a timber building, similarly, well, not similarly, you have to have bracing. This is the bracing. Also, across the top. That will prevent when the ground is stiff, that the building itself will stay intact. Without those members, the building will fall apart. These are some illustrations of what happens when you have very powerful wind. Of course, this wouldn't happen, hopefully, in a concrete building, but in a wooden building, it would blow it off. Of course, the roof, the windows, and the doors are the most vulnerable parts of a building when it comes to high wind.
Yeah.
You have issues where the veranda is separated from the main building, but the roof is one continuous roof. You get the roof, because it's covered an open area, is very susceptible to blow off. And if it's attached to the main roof, it could quite easily damage the main roof where everybody is sheltering. The last one, flooding, of course. We all know about what can happen, not only from flooding in that situation, but also landslide arising from torrential rains. So similarly, when you come to roofing your building, the hip roof is the best type of timber roof that you can use. Because it's held long on all four sides, it is better able to resist the wind. But at the same time, the gable is also good, but not as good as the hip. The flat roof really should be avoided at all costs. The angle, what you call the pitch of the roof, should be not less than 25 to 30 degrees. Not less than. It can be more, but not less than. This is because as the wind passes over the roof, it tends to suck it out. And if the pitch is too low, the suction is much greater. With a steeper angle, the suction is kept to a minimum, so there won't be so much force sucking up the roof. All right, also the building site, where the building is sited, the location of the building. Depending on the topography of the land, some areas are subject to much higher speeds of wind, higher wind speeds. For example, the brow of a hill, the edge of a cliff. In those locations, the wind, while somewhere it might be 100 miles per hour, in those locations it might be 150 in the same hurricane. So when houses are situated in those areas, one has to bear in mind that the wind will be higher, so therefore you have to make it that much stronger. I'm not saying you cannot build there, but just be aware that it's highly vulnerable to wind, so we need to make it much stronger. Of course, ravines and streams, building close to them, it puts you in a vulnerable state because you don't know how high the flood waters will come, given our recent experience with Erica, where streams that we have known to be little things all our life became monsters during Erica. So we must give all ravines and streams quite a lot of respect because we've seen what has happened. Yes, just to go over the roofs. So in the course of your discussions with your architect, who would be the ones mainly involved in those type of things, these are issues that you can be aware of, that you can ask him, make sure he does it this way and that way. And if he does it another way, ask him well, why he did it that way. So because you're the one going to be living in the house for the life of the house, so you want to make sure that you are safe inside of that house. All the members, of course, everybody know about hurricane ties, tying down the rafter to the plate, or the ring beam as the case may be. But apart from the rafter to the plate, we also need to tie the purline, which is the member that the galvanized is attached to, also tie it, prevent it from coming apart. It's not sufficient just to nail it. What a nail can do, really and truly, when it comes to resist uplift, it will prevent it from moving sideways, but it doesn't prevent it from coming apart this way. A man with a hammer can take a claw hammer, he can pull out the nail, much less for strong wind. So we need to have something that will hold it down. Apart from the nail in it, we need to have a clip that will prevent it from moving apart like this. Many times they have the hurricane ties, but they don't have the tie from the purline to the rafter. So the wind will come, and the wind will take the galvanized together with the purline and leave you with rafter, which just defeats the whole purpose. You don't want anything to go, because it's you inside there, and your property and everything else. The sheeting has to be tied down, or better screwed down to the purlines. And you have, because the suction is greater along the edges of the roof and at the ridge, you want to have a closer spacing in those locations. Sometimes as much as every corrugation, you have it screwed down. Because as you know, the screw is harder to take out than the nail. This business about nailing galvanized, that thing is fast, because that doesn't have much resistance at all. So, and the screws are available, and the tools are available to implement all of that. The amount of overhang that you have over the edge should be kept to a minimum, because the longer it is, it's easier for the wind to pass and help to take off the roof. The veranda and patio roofs, like I mentioned before, you should keep it as a separate roof. It's not part of the main roof. It should start under the roof for the under. So when it does go, which is quite likely, it wouldn't affect the main roof. Similarly, you see an example, when the roof of the veranda is the same, is an extension of the main roof. It's quite easy for the wind to come and kick it off, and then it affects the main roof. So it's much better to have a separate roof. So even if it goes, the main roof still remains. Let me see what else we have there. Right. Windows and doors, of course, we have to make sure that they're secure because they can also be affected. We have to have enough hinges on our main doors to make sure that they are secure. If they are glazed, that's if they have glass in them, we have to provide them with the necessary shutters to prevent breakage. The walls, of course, subject to suction and pressure. They don't usually fail, but given the way some of those walls have been built, I cannot say that they wouldn't fail, because if they didn't put the steel the correct way, and they didn't align the blocks in the proper fashion, it's quite easily that the wall could fall in, or suck out, as the case may be. Of course, it has to be tied down in the bottom, the steel has to come from the floor, and end up all the way in the ring beam to make sure that the wall is secure both top and bottom. And in addition to that, quite often the masons that have leave that up, we have horizontal reinforcement. Every third row of blocks, there's supposed to be another layer of steel in the joint of the block to tie the blocks at the end. So the wall is tied top, bottom, and sides. And in that way, the wall is made secure. It's because we live in a hurricane and earthquake zone, we have all these extra things to put in. If Dominica wasn't in those locations, some of those things we wouldn't need to put it in. Because the loads that the building would be subject to would just be what we call gravity load. That is the everyday type of load. Like we sitting down here is gravity load, you know? Yeah. But hurricane and earthquake is what we call lateral loads. The loads come from the side. And if the building not reinforced or designed to take those those roads that come in on the side, of course the building will be affected. Okay, so I leave a little time now for questions from the floor. I know I haven't touched on everything, but if you have any specific concerns, perhaps we can deal with them.